So you just picked the one you didn't like. You chose the one of these that looked ugly to you. Well, I worked them all. Okay? So to find the inverse, it's the same 3 steps every time. Switch your x and y, solve for y, rewrite using inverse notation. Okay? Now, I leave them in this form, even though not all the answer keys leave them in this form. I leave them in this form because I can clearly see when they're in transformational form that this translation point is 1,8 and this translation point is 8,1. That makes me happy. That gives me some indication that I did my work correctly. Yes, ma'am?
Should it be plus 3 in the number 2, or is it minus 3?
A number 2 should be plus 3. It does appear that I had an oopsie. Thank you. Nice. Did I miss any others? When we start with a cubic and end with a number 3. When we start with a cubed root and end with a cubic, no. Because both the domain and range of every single cubic and cubed root is unrestricted. It's negative infinity to positive infinity. So the one thorn in our side is number 5. It is the square root function. So when we think about the graph of this function, it is shifted over 5 up 2. So its inverse would be reflected across the line y equals x. So it would just be the right side of a parabola. See, the domain is restricted to just the right side. Good. Hooey.
Oh my gosh,
There was some concern in the classroom. Okay.
He literally sleeps and he gets like 130.
All right. So, today we're taking it a step further and using something we already know, which is kind of good, but it's helping us also review for things we need for our test. Today we're going to use composition to determine if functions are inverses. And the cool thing about using composition is normally when we compose f with g and g with f, we do not get the same thing, do we? But if f and g are inverses of one another, then, this is an if-then statement, which is a conditional statement from geometry. Then, the composition of f with g and g with f always equals x. Just x. Not negative x. Not x plus 2. Not 3x minus 5. Just x. So, if they are inverses, when I do the composition, f of g, g of f, both ways, we get the same thing. Which is really cool, because normally you don't. Normally, if you compose f with g and g with f, you get different things. But when they are inverses, you get the same thing. And it is just x. Not x squared, not 3x, not x plus 1. Just x. Okay. So, what I'm going to do is I'm going to show you how this works. So this is one we just did. Maybe. Hopefully none of you picked the line, because the line was the easy one. All right. But we're gonna try 2 of these. If we do y composed with y inverse, or y inverse composed with y. Now remember, I could write it like this, or what's my other notation? Y of y inverse of x. Or the other way, y inverse of y of x. Remember, these are the same. Those mean the same thing as a little open circle. What does a closed circle mean then? Multiply. Open circle, composition, closed circle, multiply. Okay, so let's remind ourselves how to do composition. So in this case, y inverse gets plugged into y. So y inverse gets plugged in to y.
Okay, that's not.
It's not bad. It's not bad, is it? I like it. So 3 times x plus 6 over 3 minus 6. So all I did was plug this in where x was.
Oh yeah, it's X. I just calculated it out. Yeah, it's X.
Good. You were so right. Now let me show everybody else how that works. The 3's are going to cancel, and we're left with x plus 6 minus 6, which is just x.
X.
It's just x. Now, when I do it the other way, guess what I'm going to get? X. Let's prove it. All right, switch to pink, just
So
for
why
fun.
you should write it?
Now we're going the other way. All right, so this time, 3x minus 6 gets plugged in here where x was, plus 6 over 3. What happens with the plus and minus 6?
0.
They cancel. What happens to the 3's?
Cancel.
Cancel. And what are we left with?
X.
X.
Whoa.
Ooh. So whether I did y inverse of x or y inverse y of x, both ways I got x. They are inverses.
So when they like the inverses multiply together and they got X, they're inverses, right?
Correct. Composition, not multiply, but
Okay.
I think you
Sorry.
were on the right path there.
Yeah.
All right. Now this one is uglier, yet not hard. Okay. One thing we always like to look for, because we're human, is the easy way out.
Yes.
Don't just automatically make everything cancel because it looks pretty. Because Miss Meanie Willoughby will create two functions that might look like everything would cancel pretty, but beware, they may not. Okay? All right. All right, but we know these will work because we just found that they were inverses. So we know they'll work. All right, so let's do y inverse of x. Whoops. Let's do that first. So plug in the inverse into the original function. Looks weird. I'll tell you, because x is right here under a radical. So this stuff, x minus 8 divided by 2, all cubed plus 1. And then we had
Plus 8.
Maybe minus.
minus, well no, this is plus 1. Let me change the color of this. Let me change the color of
Oh my
this.
god.
All right, so that's the original function. Let me change the color of what I'm plugging in so we can see it. It was too much pink. It really was just too much pink earlier. All right, so this gets plugged in right there. All right, now I'm going to carefully, slowly, and thoughtfully start to cancel things. All right, are we ready?
Yeah.
Mhm.
Yeah.
All right, here we go. Cancel, cancel. Happy?
Yes.
All right. Cancel, cancel. Happy?
Yes.
Yes. Cancel, cancel. Happy?
Yes.
Wait.
Twos. Twos just win.
Oh, because the 8 and the.
Wait a minute.
That's okay. I'll change colors every
so
time.
you can just
You
cancel
should
like
use
this.
Okay, different colors, different colors. I got it. Blue, blue.
Mm.
Okay? Orange, orange.
Hmm.
Okay. Now we'll go back to x minus 8 is what's left.
That's a lot.
Plus 8.
And then plus 8 at the end. And now what happens?
Cancel.
Cancels.
Yeah.
Alright. Cancel, cancel.
Yeah, back to the pig.
And
Okay.
then X.
And we're left with X.
Happy number. Love it.
Okay, so you try y inverse of y of x. You try that composition now. What are we going to get? X. Alright, so let's see if you can actually get it. I believe in you.
At
Wait.
least somebody does. Oh, wait.
What's the equation?
We are recording.
This is gonna be a fun one to listen to.
Are we using number 3?
Yeah, number 3.
Okay.
Big work.
I'm really kind of curious if there's not like a full moon or something today because fourth period's recording was so bad I can't even post it to YouTube.
Well, so
Oh my gosh.
It was bad. I'm just going to email. I'm going to put it in my Google Drive and email a link to the one person that was out today because they were bad.
Well,
Are we bad?
No, y'all aren't bad.
Oh, yeah.
Y'all are just funny. All right. So Y gets plugged in here. Oh goodness, that is not enough little space.
Wait.
I arrowed over.
All right.
But now I can't see everything I want, so I'm arrowing right back. All right, I'm going to do it right here. I'm choosing black. All right? So, this time Y gets plugged into Y inverse. So I'm going to write down Y inverse. And then I'm going to plug in Y.
Wow.
Yeah, that was bad.
Oh, because now you're plugging in Y into the. Okay.
Yes, that is exactly right.
I-
Okay, so now it's canceling time. I'll start with yellow. 8s, cancel. I'll go to green. The 2s, cancel. I'll go to orange. The cube root and the cube, cancel. I really feel like it's now time to rewrite. So, what is left is just the x minus 1. But what is left out here? Plus 1. So we'll finish off with pink. And we'll say cancels, cancels. And my answer is
X.
X. Okay. So, what happens when I give you 2 that we haven't proven are inverses? Like numbers 1 and 2 on the back. Alright? So, these kind of look like inverses. A line and a line, a cubic and a cubed root. But to prove that they are inverses using composition, which will be the exact directions on your quiz. It'll say using composition. So you must use composition. All right, so let's do f of g of x, and then let's do g of f of x, and see what we get. All right, so this guy gets plugged into that guy. So 2. 1/2 x plus 5 minus 5. Already see a problem? You might already see it too. So when I go distributing, this part works out good. X. I'm looking for x. But then I run into the problem. Plus 10 minus 5 is not just x. Not inverses. I don't even have to do this one. This one just proved they are not inverses.
What if the other one was x plus 5?
It doesn't matter. It's got to just equal x, and it didn't.
So if you
Only way.
check, it would just like
You could check. And what you're going to find is it doesn't equal x.
Yeah, I mean, so if we want to check, so just find is x, then that's right?
If we just get x, then we're right.
Oh,
All right,
okay.
so G gets plugged in. All right. Cancel, cancel. X plus 3 minus 3. All right, it's looking promising, guys. F of G of X equals X. All right, now let's show it the other way. Now, you guys are going to get to the point where, like, Miss Willoughby, I know it's always going to work the other way.
So do we
Which
have
is
to do-
true while you're sitting in Algebra 2. Because we only play with easy functions. We use nice, simple functions. There are much more complex functions. And it is very possible to, well, one day you will run into one that you must show both ways. Because one way will give you a hiccup and the other will not. Yep. Alright, so here we're going to plug f into g. So we get cube root of, plug it in, x cubed minus 3, and then we have that plus 3 at the end. Cube, cube. Alright, g of f of x equals x. We proved it. They are inverses. Okay, so there's more examples if you'd like to try them. But I think we've done enough. So I'm going to go ahead and give you your homework.
I think this was